Today I'm done a call about the carbon emissions of the cloud. So I'm Olivier Bierlaire. I'm currently a software engineer at Elastic in the releasing team, but I'm currently doing a break and working on Carbonifer, a tool for measuring and reducing the carbon emission of the cloud. So this is a sentence I hear quite often, is I have all my infrastructure in the cloud, so I do not emit CO2. Yeah, that sentence you probably have here quite often too. And yeah, cloud is magic, but it actually relies on servers and data centers. And those servers and data centers are powered by electricity. And yeah, electricity is clean, right? Not really. So let's look at the numbers. Let's have some figures. So we considered that if you take all the energy used by the digital sector, like smartphone, television, and even data center, data centers are using 25% of this electricity used by the digital sector. It's considered to be a bit more than 1% of the total electricity used worldwide, excluding crypto mining, sorry. And if you look at the forecast, by 2030, internet technology is going to gobble 20% of the entire worldwide electricity demand. And data center is going to take maybe somewhere between 20 and a third of this demand. If we translate that in carbon emissions, we consider that the cloud is currently emitting more than 300 megatons of CO2, which is around the same emissions as countries like France or UK. So it's basically another country. And it had recently overthrown the civil aviation. So basically data centers and the cloud are already emitting more than planes and all the flights in the world. And we consider that by 2030, it's going to be responsible of 8% of the total greenhouse gas emission worldwide. So 8%, that's huge. So that's really concerning as human being, but as company, what's the problem? As a company, there's a lot of regulations and laws that are coming pretty soon. A lot of countries and regions are voting some laws and regulations of that. I'm going to talk about that a little bit later. But you have also ESG funds. So a lot of investors, they want to invest in companies that are showing some sustainability and some greenness, let's say. And obviously, as a company, you want to attract them. You also want to attract and recruit some staff. And it has been shown that as a candidate, you are more keen to join a company which is showing some responsibility, ethic, and sustainability. And it's also true for customer retention. Of course, as a customer, you are more keen to buy or to use a product which is sustainable now. And obviously, there is a little bit of cost reduction if you are a little bit greener, and I will show you later why. So what are we responsible of? There is this GHG protocol. It's gonna talk about 3 scopes. The first scope is your direct emission. So that's the more obvious, like if you have a diesel generator for your factory, that's direct emissions. That's pretty obvious, that's scope 1. For scope 2 is indirect emissions. So basically, if you are purchasing energy on the market, electricity or gas, the emissions generated by the production of this electricity is going to be accounted in your scope 2. Scope 3 is other indirect emissions, like business travel, raw material purchase, but also service purchased. And your public cloud subscription, such as AWS, GCP, etc., is accounted in service purchase, so it's in scope 3. So basically, if you are operating a private cloud, you're going to be accountable for scope 2 and 3. Scope 2 for the electricity used by your data center, scope 3 for the hardware you bought. And if you are a customer of a public cloud, you are responsible only for scope 3, for the energy and the hardware required by your data center. So there is also some regulations and some European regulations that are interesting. You have heard of that already, the CSRD. So it stands for Corporate Sustainability Reporting Directive. So it's European directive, which is going to be enforced in 2024, so next year for a large company, and 2026 for listed SMEs, and it's going to encompass scope 1, 2, and 3. So if you're working, these large companies going to be required to account and report those emissions. Just report. We're not talking about reducing yet. And the SFDR is also quite interesting. It's more for the financial sector, and it required for them to account scope 3 of the company they are investing in. So the carbon emissions of the company they are investing in are going to be accounted in their reports. So on top of those regulations, there's also some commitments, and we often talk about CO2 offsets and eliminations. There is a big difference between those. CO2 offset is either you are compensating or you are removing your CO2 you have emitted. So basically, it's planting trees. There is also some direct air capture, but the most things you see currently is still planting trees. Elimination, on the other hand, is just not emitting CO2, or just remove the source of production of this CO2. So those both are different. And if you talk about those commitments, carbon neutral, net zero, and 100% renewable, they are focusing either on offset or elimination. For carbon neutral, is focusing on offset. So basically, you're still emitting the same number of CO2, but you are compensating. You are planting trees to compensate that. For net zero, you are focusing on elimination. So it's going a little bit further, and what can't be eliminated is going to be offsetted. And if you hear about 100% renewable, you need to be careful if it's powered by renewable energy or matched by renewable energy. It's just a matter of time. Powered by, that means you are sure that 100% of the time an electron coming in a data center comes from a renewable source. So if you have your own solar panel and windmill and you're sure they are working 100% of that time, that could be true. But most of the time it's matched by, which means, like, for example, if you have that solar panel on your roof and you are emitting twice your need during the day, you still need to buy electricity on the market during the night. And this electricity is maybe coming from non-renewable energy. So in that case, matched by, it's a little bit debatable. So first, I'm going to make a quick poll here. Is some of you are working in companies who are operating a private or customer of a public cloud like AWS or GCP? Yeah, pretty much everyone. And can you raise your hand if you are involved somehow as software engineer or DevOps, SRE, infra team operating this cloud? Yeah, maybe half of the room. And keep your hand up if you know how to get the carbon emission, the carbon footprint of your company for the cloud operations. Pretty much no one. Yeah, actually no one. Yeah. So what are we talking of in terms of energy? So let's have a look at in the electricity journey in the data center. So basically you have electricity coming from various sources. Some are fossil fuels, some are renewable energy. Some is nuclear, so nuclear is a little bit debatable, but still classified as clean energy, not renewable, not green, but still clean energy in terms of CO2. The electricity entering your data center, there is a little bit of this, which is going to be used by the AC cooling system, heating of the building, stuff like that. But the large majority of electricity is going to actually power the servers. And if you have virtual machine, a Docker, piece of code, software running on those servers as a customer of public cloud or as actual user of your private cloud, we have ways to calculate what the share of this electricity you are responsible of. So the Green Software Foundation, I encourage you to check what they are doing, came up with this formula. This formula is called software carbon intensity. So it's basically, that's pretty simple, is if you know what is the power used by your software, You can multiply it by the carbon intensity of your energy source, and you add the electricity used to manufacture this hardware. So I'm going to explain a little bit later. And at the end, you're going to have a score in gram of CO2 per hour. We are talking about gram of CO2 equivalent, actually, because there is not only CO2, but also methane and other greenhouse gases. And for example, methane is 84 times more potent than CO2. So that means that in order to rationalize that, we picked the most known one, which is the gram of CO2 equivalent, but could be some other gas. So I will talk about the last one first. Is what we call the embodied emission. So it's basically the emissions the emission of CO2 while the server has been manufactured and when it's going to be disposed. So it's encompass both. So basically, if you take this example, you have bought a server which have emitted 4 tons of CO2 during this creation, and you're gonna use it for 4 years. Each year, basically, you are emitting virtually 1 ton of CO2. And you can even go down and take ratios for your time unit or your share of usage of this hardware. So now to go back to the formula, the E multiplied by I is the energy of software, the energy of the software of your VM. So it's expressed in kilowatt hour, multiplied by the power usage effectiveness, and multiplied by the carbon intensity of the grid. So let's take an example. If you have a M4 large machine on AWS, which has 2 virtual CPUs and 8 GB of RAM, and imagine you use it with a load of 50%. So with some calculation, and you have a lot of methodologies and different tools to calculate that. So let's assume that in this example, it's emitting 10 watt-hour, which is 0.01 kilowatt-hour. You are based in Germany in this example. So in Germany, AWS have a PUE of 1.2. So what is PUE? Basically, if you need 1 kilowatt-hour of electricity in your server, because there is a lot of loss and a lot of other use in your data center for electricity, such as cooling, air conditioning, etc. So in this example, for 1 kilowatt hour, you will need to inject in your data center 1.2 kilowatt hour. So that's what's called the PUE. And then the carbon intensity in Germany on average yearly is more than 300 grams of CO2 per kilowatt hour. So if you multiply all of these numbers, you come up with 3.8 grams of CO2 per hour. So to come back to the full formula, if you have your the footprint of your software, the use of the software, the E time I is 3.8, and you have your embodied emission, for example, 1.2 grams of CO2 per hour. Remember, you take the full lifespan of your server and you divide it by the number of hours in this lifetime and the actual load on it. So you have a lot of data sets and a lot of sources to get that. And it's, in this example, 1.2. And at the end, you can say that your software carbon intensity is 4 grams of CO2 per hour. So every hour you're running it, you're going to emit 4 grams of CO2. So where to find those data? The first way to find this data is to look at your grid provider, like Enedis in France, for example. They are publishing this data. Big cloud providers like AWS, GCP, they also publish their data of their average carbon intensity. They also claim that they are 100% compensated, so they're going to tell you as well that it's emitting 0. But, for example, Google have a little bit more transparency, and they give you their raw number before compensation. And there is a very interesting app named Electricity Maps. So if you are going to app.electricitymaps.com, you're going to be able to have the live carbon emissions of your regional provider. So in this example, in March 22, in France, it was emitting 157 grams of CO2 per kilowatt hour. So anytime you need a kilowatt hour, it's going to emit 157 grams that day. And also they are publishing their power usage effectiveness, which is quite useful for making this calculation. There are some data that are less available, which doesn't mean it's not, you cannot find it. It's just a little bit trickier and a little bit debatable the way to get it. For example, the energy consumed by the hardware. You need to have, so if you take my example on AWS M4 large machine, what is the CPU make? It's already hard to find. And once you have your CPU make, you need to find some benchmark telling you what is the consumption profile of this CPU. And obviously it's not linear. It's still using electricity even if it's idle. And if it's 50% or 100%, it's not always linear. So it's a little bit complex to understand that. Same thing for GPU. Strangely for GPU, it's a little bit more easy to get, probably because it's heavily used in crypto mining and AI, machine learning, etc. So people are maybe more concerned about that for some reason. And you also have debates on the percentage of usage, the unit of this percentage of usage. So it's quite complex to get those numbers. Same thing for memory, storage, and network. So for that, we are taking estimations as coefficient. And most of the time, they are good enough, to be honest. Like it's just tiny percentage of difference between different memory manufacturers or stuff like that. And at the end, if you are taking the same kind of estimation and coefficient, relatively, you are good with the previous calculation. Also getting the embodied emission of hardware. So again, it's how many CO2 it has been generated while building this hardware. It's pretty hard to find. You have some data set existing, and again, it's still estimation because you are not sure if your server has been made in China. You are not sure that day in China what was the carbon emission, etc., etc. So it's all average and estimation. And if you want to make decision, you can look at the weather prediction because renewable energy are really influenced by the weather. And as you can know, the weather is more or less predictable. So having the carbon intensity of your energy mix and have the weather of that is a little bit tricky. But fortunately, there's tools to help you doing that. The most obvious one, and maybe the most known, is the carbon footprint dashboard of those major public cloud providers. So for example, AWS, GCP, and Microsoft Azure have their dashboard. Most of them, those dashboards are pretty high level. They are working with quite old data. So for example, for my consumption of last month, I still not have the data yet. But I guess they are making improvement on that. And it's still like in one click, you have your answer. The question I asked before, what is the carbon footprint of your cloud infrastructure? If you are on those data centers, yeah, you have it in one click. Done. If you want to go further and deeper, I encourage you to use this open source tool. It's called Cloud Carbon Footprint. It's made, sponsored actually by ThoughtWork, and it's actually read the bill. So in the bill of your cloud provider, you have the actual usage of each resource, the number of hours you use, an EC2 instance, etc., etc. And it presents you the data in this beautiful dashboard, and you can deep dive and have like what's the consumption, what the carbon emissions of this environment, of this database, etc., etc., and you can just have more correlation and more thinking about your carbon emission. So you even can check the demo to play with dummy data. So if we want to go, so that was basically generalist tools. So for those other tools, they are focusing on some estimations. So for example, Climatic, it's a commercial API, just an API, and you just can request what is the carbon emission of a resource. So in this example, you are on Azure, in UK, you have an instance H8, and you run it for 24 hours, and it tells you that it's going to emit 0.74 kilograms of CO2. It's pretty simple, but the great things with Climatic, it's also have a lot of estimation factors like transportation, freight, etc., etc. So that could be useful to be used at the company level and not only as at the cloud level. Another one who is open source, and it's a free API, and I have a free dataset and a lot of datasets and raw data you can check, is named Boa Vista. So it's pretty much give you the same information. It gives you the use of your the CO2 generated by the use of your instance, but also the manufacturer, which is the embodied emissions. Be careful with this embodied emission because it's the total embodied emission for the lifespan of your server. So you need to make your own calculation if you want to have the share of the time you actually used it. If you want to go even deeper and more accurate, you can try to find the actual power consumption of your software. You have this tool named Scaphandrer. It's made by Hublot. It's an open source tool, and it actually reads the power consumption of the CPU. And then after it correlated with the different process, the share of those process in terms of use of CPU and RAM, etc., make you some calculation and tell you that this process, this software, needed this number of kilowatt hour to run. It doesn't do any CO2 estimation, but actually, from my point of view, it's probably the trickiest part of this calculation is to get the power used by your software. Again, you have a demo here. You can click and have some dummy data and play with. And finally, the tool I'm working on, it's named Carbonifer, and there is actually already an open source brick, so it's going to be different brick, and this open source brick is a command line tool to estimate your Terraform project. So if you are not familiar with Terraform, Terraform is an infrastructure as code tool. So basically, you are describing as a code what the infrastructure you need. So in this example, you have a compute instance on GCP. And if you apply this playbook, let's say, it's gonna deploy the instance. And what this tool is doing is actually read that and tells you that what's gonna be the carbon emissions of this instance per hour, per month, if you are deploying it. So I'm gonna do a very quick demo for that. Is it big enough? Try to, okay, it's gonna be too big then. Okay, so in this example, I want to deploy an instance in Germany, and it's gonna be M4X large, and I want 10 of them. So I'm gonna run Carbonifer plan, same way you're doing Terraform plan, and if it's working, yeah. Tells you that those 10 instances in the year after the deployment is gonna emit 600 kilograms of CO2 equivalent. That's pretty simple and straightforward tool. Done. So now we know how to measure it, we can start to reduce it. So there is one thing you need to do first before doing anything else is trying to optimize your software. You have a lot of eco-design and green coding good practices. There was a session this morning telling you a lot of tips around that, and I encourage you to watch it. So yeah, basically optimize your software. Obviously, if you are not optimizing your software and just optimizing your infrastructure, it's probably like you're probably doing it in the wrong way. The other thing is to exactly choose what you need at the minimum. Like try to size the right size of instances you want, and obviously taking the last generation. Like if you are requesting on AWS Graviton instances, it's like regular CPUs are gonna emit around like are gonna use 8 kilowatt hour of power, and Gravitron is less than 1. So yeah, that's a big win. But migrating to Gravitron is not that easy in some cases, so let's check some other ways. One obvious way is also to migrate to some hyperscalers. Why? Because they are making a lot of effort, and a lot of efforts you will not do by yourself. So on AWS, GCP, and Microsoft, they are all committed to be net zero by 2030 or 2040. And even Microsoft want to be carbon negative. So what is carbon negative for them is they're gonna claim to capture more CO2 than they're gonna emit it. It's interesting. You have also some smaller cloud platforms like Denver or Exascale, which could be interesting in some cases. Exascale, they are based in Swiss and they're all powered by 100% hydroelectricity, which obviously is almost zero emissions. Beware, there's still the embodied emission, but at least for the use emission, it's really, really low. And you can also move to, there is another very small project, new project in Nantes called Denver. So the idea is to have a floatable data center on water. So basically the data center is gonna be cooled down by the water directly, by the river. So it's pretty interesting, it's pretty early stage project, but I encourage you to have a look. And also why it's interesting to move to hyperscaler is because you don't need to buy and manage your own data center and your own servers. Obviously, if you want to make sure it's gonna be able to have the traffic you are planning, you tend to overcommit and have numerous unused servers. While on the cloud, you can just scale it when you need and have only the number of server you need at the highest load you can afford. So basically, at the end, it's gonna emit less CO2, let's say. And those data hyperscalers are making a lot of effort on PUE. For example, they're like Denver, I mentioned, they are making a lot of effort on their PUE with natural air conditioning. They're also increasing the lifespan of the hardware. Obviously, if you normally use your hardware 4 years and you try to use it 6 years, you are reducing by, I don't know, 20% the carbon emissions, the embodied carbon emission. And they tend to move to renewable energy and buy on the market only renewable energy. But be careful on rebound effect. That means that if you're responsible for less CO2 emission, you tend to basically use more and increase your CO2 emissions. So be careful of the rebound effect. There is also some interesting practice coming from the FinOps world. So FinOps world is like the financial branch of DevOps, which means you are using automation to bring the cost down. So basically by using auto-scaling group or scheduled scaling. So basically you are shutting down instances during the night and bring them up during the day. And auto-scaling group is most of the time based on traffic on the load. So basically if you don't have traffic, it's going to scale down your group and it's going to scale up when there is a lot of traffic. So in that case, you're going to use only what you need in terms of electricity. And maybe if you can move serverless, so serverless still mean you have servers, but at least they are not used if you don't have any traffic at all. And obviously that can lead to less dollars spent. And in that case, less dollar equal less CO2. So obviously you would like to choose your region wisely. Why? Because different countries have different energy mix. And if you pick the country with the best energy mix, it's gonna really reduce your carbon emissions. In this example, those are numbers coming from Google. If you are based in Paris, you will have probably the greenest electricity in Europe for Google. It's probably greener in Sweden or in Swiss, but they are not based there. And obviously there are some other countries which are powered by coal and gas, and you would like to avoid it if you can. Obviously there is some drawbacks with that, like you probably have some latency problem if you are further from your users, but that's your decision. Another good practice is basically following the sun. Like you check, I mentioned electricity maps, and they have some good graphs where you can see when was the time where the electricity was emitting less CO2. So in that case, yes, check that and try to schedule your task or scale when the electricity is going to be less carbonated, let's say. And finally, try to move to carbon awareness. So what is carbon awareness? It's that your software, your infrastructure, is going to be aware of the carbon it's emitting and try to self-adjust because of these carbon emissions. So there is 3 ways it can act on resizing, moving your infrastructure, or scheduling tasks. So the first one is what we call the temporal shifting. So the idea of that is to schedule your task, it's most of the time asynchronous task, when the electricity is going to emit less CO2. A good example is image or video processing, or AI model training or machine learning that could wait to be done like the day after or in a couple of hours, DB indexing, etc. At Google, they try to use it, and now they're using it. They claim to use it pretty much everywhere, where they will run asynchronous task when the electricity is emitting less CO2. The other one is named demand shaping. So basically, it's try to adapt your quality of service on the carbon emission of the electricity at that time. So, for example, I heard about this small project where I think it was a university. Their video did not have any pictures when the electricity was emitting a lot of CO2. And it was showing pictures back when the electricity was going a certain threshold. There is also that could be also implemented on CI. For example, if you are building your PR or any CI and you are reducing the number of workers for this CI when the electricity is emitting a lot of CO2, it will basically reduce the CO2 you're emitting, and your users, the developer, will need to wait a couple of minutes more. But yeah, it's just a matter of adjusting that. And finally, the spatial shifting. So basically, it's where you will move a part of your infrastructure when the electricity is emitting too much in your region to a region where it's emitting less. There is one study which have been shown in Hot Carbon 23 conference, where they show that by having basically two group of instances in two different regions and have a load balancer, not picking the region where you have, which is closer to the user, but picking the region where the electricity is emitting less CO2. And they noticed by doing that they reduce of 21% their emission without any increase of latency. And if they have acceptable latency, can bring that down to 51%, which is already great. So I'm gonna make a quick demo around that. So yeah, I'm gonna explain first what's the architecture look like. So in this demo, so imagine you have a global load balancer which is responsible for getting the request from the user. This global load balancer is gonna redirect your user request to 3 different regions, one in Ireland, in France, and one in Germany. In this region, you have another load balancer and redirect it to either of its instances there. So if you are hitting this endpoint, you either going to be replied by a server in Ireland, France, or Germany. So on that, I'm going to add a carbon aware scaler. It's going to read the CO2 intensity from any API, like electric maps, and try to guess, try to, let's say, shut down the region where the electricity is emitting the most energy, and keep up the one which is the greenest. So in this example, in Ireland is the one emitting the less CO2, and it's going to shut down all instances in all of the region and keep only Ireland up. So that is this example. So what you see is the UI of the scaler. It shows that we have actually 4 regions, and EU West 1 is Ireland, EU West 3 is France. So let's focus on those 2 ones for this example. So in Ireland, we have 2 instances. You can check that here. Yes, I am in Ireland, I have 2 instances. And if I hit the endpoint, it doesn't work, obviously. It's a demo effect. Yeah, so it should reply that, do I have internet? Okay, I don't know why it's not working. So it should basically reply that, okay, hey, I'm in Europe West 1. And I have obviously mocked the Carbon API. And it shows that, if it's still working, yeah, it shows that the different carbon intensity of those different regions. And I'm gonna artificially update the French provider to, let's say, 20. Quick check. So now the French region should be the one in green here. Yeah, it's the one in green. And then if we wait a minute, you're gonna see that the instances are gonna be moved from one region to another. It's not actually moving, it's just shutting down the one in Ireland, bring up the one in France, and actually bring the one in France first, then shut down the one in Ireland. So it's taking a little while. Yeah, in the meantime, I can show you quickly electricity maps, if internet is working there, yes. So for example, today in France is 32 grams of CO2, Belgium is a bit more than 100, Germany 280. And the good thing in that is you can dive in your region and have the carbon intensity during the 24 hours. And you can see that in Germany, it was sunny today because it's there is a peak of solar power at that time, and it's reflected on the carbon intensity of that time frame. And France, on the contrary, oh yeah, there's still difference, but France, on the contrary, is basically 70% nuclear. And yeah, we have a lot of solar panel, and it's reflected in the carbon intensity of those last 24 hours. Let's come back here. Yeah, we have instances coming. Yep, and they are not all in, so that is still not working. So if I'm refreshing, well, they're still running, but they're gonna be done soon. And in Paris, yeah, so that was probably my previous attempt. But yeah, you have 2 running instances. Going back to this, yes, and yeah, I will do that later. So yes, what we just did is that it was first in Ireland, then I artificially changed the carbon intensity of France, and the instances were probably progressively shut down and bring up in some other region. So before jumping to the conclusion, something I kind of forgot is in this example, I have everything in Germany. Let's pick West 3, like it's France. Try to run the tool again. And instead of 600 is a bit less than 100 kilogram of CO2 per year. So that's really meaningful to move your infrastructure to some other region if you can, even statically, not dynamically. So if you want to bring some carbon awareness to your infrastructure, the first thing is to collect usage metrics. Yeah, monitoring the key. Once you have that, you make some calculation to have your kilowatt hour of electricity required by your software. And then you can estimate the carbon emission of that with the formula I showed you before. Then you can plan, analyze, correlate, do whatever you want, and try to understand what's the reduction you can do, and then do your reduction. And for example, scheduling according to the grid, to the energy mix of the grid, etc. And then, if you can, bring some automation on that and have some carbon awareness. So that's all for me. Thank you. If you want to know more about that, I really strongly encourage to check the Green Software Foundation website, where they have a lot of resource there, and also the podcast Environmental Variable. It's pretty great to have that, to listen to that rather than reading. And yeah, thank you very much for questions. Yes?
How do you calculate the emission of managed services?
Yeah, that's actually a good question. So if by managed services you are... Oh, yeah, sorry. So how you calculate for managed services? So for managed services, a little bit trickier. If you're talking about, for example, RDS machines on AWS, it's a managed SQL machine, basically. So you need to pick a machine, an instance size, and it's pretty much the same calculation as the regular machines. But if you are talking about something like, I don't know, S3 or any other serverless managed service, it's or queues or something like that. It's complicated. There is a very good website you can check is the methodology page of the Carbon Cloud Footprint tool, and they're explaining their entire methodology and they are explaining how they are doing for that. But first it's hard to estimate in advance, but if you have already your usage, it's easier. For example, for serverless Lambda functions, for example, you know for how long they have run, you know what share of CPU you needed, etc., and you can calculate it. But for others, no, you take some ratios and it's not always possible, let's say. Other questions? So thank you very much.